Welcome back to our Math 171 video series. In this series of videos, we'll go over how to do basic operations with polynomial expressions. For our first problem, we'll go over how to add these large, complex-looking polynomials. In order to add these effectively, we're going to begin by writing them down based on their power of x, starting from the largest powers of x and working our way down to the smaller powers of x. As you organize these expressions, we're going to start with the fourth power in this first term, then the third power. Notice that we do not have any term for second power, therefore we're going to skip that and leave an empty space for it as we write, then go on to the negative 7x, then go on to the 10. However, do be careful to leave empty spaces for any powers that aren't there. As we write, we'll say x to the fourth plus 3x to the third. We'll leave a space for the missing second power, minus 7x plus 10. Then we'll write the other polynomial underneath it, starting from the highest power going to the smallest power. Notice that these terms are out of order. Therefore, we'll have to organize them again starting from the largest power. Therefore, we will not start with x to the third, but instead start with the higher power, x to the fourth. We'll write that underneath the x to the fourth we already have. Then we'll go on to x to the third, that's the next highest power. Then negative 2x squared. And notice we do not have a single x term, therefore we'll leave that position blank, and we'll go on to the plus 2. Now that we have our powers of x lined up, let's combine anything that we can combine by adding the coefficients in front. But remember, if there is no coefficient written in front, we'll treat it as 1. This is what I will sometimes call the invisible 1. For example, for these x to the fourth power terms, there is no coefficient. I'm going to write 1 in their place, and so we're only going to be adding 1 plus 1. 1 plus 1 gives us 2, and then x to the fourth will still be x to the fourth. We do not change the powers as we add. The same rules will apply for x to the third. Notice that we have a 3 for our first term, and then no coefficient on our second, so place the invisible 1. If you're unfamiliar with the addition, it may help you to write it in the first few times you try this. 3 plus 1 gives us 4x to the third. We add the 3 and the 1, but we don't change the power. For our x squared terms, you may see that we have only 1. So we'll write negative 2x squared. For our x term, we'll put negative 7x. And then for our constant term, we're going to add 10 plus 2. 10 plus 2 makes a total of 12. Therefore, our result is 2x to the fourth plus 4x to the third minus 2x squared minus 7x plus 12. This will be our answer for this addition. Now we'll do a variation of this problem where we are subtracting instead. Subtracting polynomials is fairly similar to the way addition works. We will make one small change to this process. The negative in front of the second polynomial will change what we do. The negative sign that's in front of that second polynomial means before we do our operation, we're going to change all of the signs on that second polynomial. This is similar to multiplying everything in that second polynomial times negative 1. Let's write that down briefly. Imagine we had a negative sign times that second polynomial. If it helps you, we can write an invisible 1 in front of the negative sign. And now just imagine, take that negative 1 times each of the terms inside. We will say negative 1 times x to the third. This will give us negative 1x to the third. Then negative 1 times negative 2x squared, giving us positive 2x squared. Same negative 1 times x to the fourth will give us negative x to the fourth, and then take that negative 1 times the 2 to give us negative 2. Now, we're going to organize that starting from highest to lowest power. So we will have negative x to the fourth minus 1x to the third plus 2x squared, leave an empty space for the x, which does not appear, minus 2. Then above that, we'll write our first polynomial. So just to clarify, in the first line, that is our first polynomial, and then in the second line, we have our new second polynomial after changing all the signs. Now when we combine these, we'll put the invisible 1's next to the x to the fourths, so we have 1 minus 1. But 1 minus 1 is 0, and anytime you get 0, you don't have to write it, and you can leave that term out. Therefore, I'm going to cross out the x to the fourth terms to show that 1 minus 1 gives 0, and we will not have any term that is x to the fourth power. Next, we'll move on to x to the third and take 3 minus 1, and that is 2x to the third. Once again, we do not change the power for subtraction. Next, for x squared, we have a single term. That's 2x squared. For x, we also have a single term, minus 7x, and then 10 minus 2 will give us plus 8, and then this will be our answer for the subtraction. 2x to the third plus 2x squared minus 7x plus 8. So subtracting polynomials is fairly similar to addition, just with that extra step where we change the signs.